I think everyone has a natural interest in astronomy, because all you have to do astronomy is just look.
One thing that just always gets me excited is when I get to go to the telescope and peek up at the sky and see what I'm getting to do. That never disappoints.
I read Carl Sagan's book, Cosmos. Once I set that book down, I didn't want to do anything else.
Back in the late 40s and early 50s, Clyde Tombaugh was working out at White Sands. In about 1965, Vice President O'Donnell approached him with the idea that maybe we should start a graduate program in astronomy. By 1969, we were established as the Department of Astronomy. My husband came at that point in time as an assistant professor, and we did our first serious recruiting of graduate students that year.
And it was obviously smaller then than it was now. It's kind of been a period of gradual growth over the last 50 years or so. A lot of the work in the first few decades is related to the solar system.
For the past 20 years, I've been working on dealing with NASA's planetary atmospheres data. We archive it here at New Mexico State.
I've always been attracted to planetary science because those are systems where we can actually send a probe or maybe even send a person. My research focuses on atmospheres of planets in our solar system, and most of my work has involved the atmospheres of the giant planets, the gas giants, so Jupiter, Saturn, Uranus, Neptune.
You know, if you were to go to Mars, I mean, a lot of things would seem different, but it really is a lot like Earth. My research is focused on the weather and climate of Mars. It has similar weather phenomena to Earth. I mean, there are dust devils on Mars. We have dust devils here in southern New Mexico.
As technology has evolved, we've become involved in a much larger ground-based telescope project here. And our research areas have broadened beyond the solar system into physics of galaxies and, in fact, the structure of the universe as a whole, cosmology. Recently, we've expanded into solar physics as well.
In our group, we want to know why the sun works the way it does, how it works the way it does. We use the sun as a model to then understand other stars.
My particular field is studying their interiors, what happens on the inside of them, the stuff that we can't actually observe directly.
So me and Jason work pretty well together. He does the inside of the sun, I do the outside of the sun. We interface at the surface.
So one of the biggest resources that I have access to for my research is Apache Point Observatory, and specifically the 3.5 meter telescope.
Not all astronomy departments have access to a sort of 3 meter class telescope. We're allowed to get a lot of time on it, and we can actually push our projects forward more rapidly.
I was postdocing in California and then applying for faculty jobs, and one of the attractions was that Apache Point was just starting up, so that was the decisive factor in the end to come here. I've been doing research in interstellar medium and galaxies. And so the interstellar medium is the medium that is between stars, and this is in the form of gas clouds and dust grains.
Apache Point Observatory is home to several telescopes, not just the 3.5 meter telescope.
The second largest telescope at Apache Point is a 2.5 meter diameter telescope, and that's the telescope that's been used for the Sloan Digital Sky Survey.
The Sloan Digital Sky Survey started as a large imaging survey of the northern sky in 5 different colors. And then it expanded in the subsequent phases to not only do imaging, but also do spectroscopy, where we get detailed spectra of individual objects.
We actually study how galaxies form by looking at the invisible gas which flows into them and flows out of them.
I'm focusing on regions of the universe that you might call galaxy nurseries, where young galaxies are forming and evolving. And I'm using big telescopes to actually take images and spectra of the real universe.
Spectroscopic data is the type of data where you disperse the light into the rainbow and can study relative brightness in different colors.
And so we usually combine images with spectra to answer our science questions.
So cosmology is a branch of astronomy which studies the origin of the universe. So we start with very, very large distances and early times of the formation of the universe, and from there we make some predictions and we follow those predictions, and afterwards we're testing that against the observed universe.
Theorists don't look through telescopes for the most part. We try and use what we understand about physics and what we understand about mathematics to understand in as simple a way as possible what we learned from the observations that the observers make, which are very difficult to make.
In the astronomy department, we have an interesting mix. The astronomy department does not have an undergraduate major, but we do have a graduate program. So the mix of classes we teach includes some graduate level classes, but at the undergraduate level, we're a big provider of general education courses.
I teach undergraduate introductory astronomy, which I love teaching because you get all types of students with all different backgrounds who are in that class for all different reasons.
In graduate school, teaching different techniques, different methods, different, again, ways of looking at the universe.
Is I want the students to develop the ability to create an opinion and then find ways to support it.
I think the main thing for me that I'd like to bring to the classroom is the idea that we're always growing, we're always learning, and there's never a better time to learn something than right now.
The Voyager mission was fantastic because, to be corny, we went where no man has ever gone before, and now we've got another one.
Before New Horizons flew, we knew very little about Pluto. And now that we have sent a probe out there, this place which was just a dot is now a world. And we can look at it and we can see maps that have incredible resolution. We can see that Pluto is actually very much alive.
Clyde would be delighted with it. As a matter of fact, he would probably be just bubbling over the whole thing. He was proud of his discovery, but he was also really intrigued with discovery.
My favorite thing about doing astronomical research is piecing something together that's new, that will somehow trickle down and affect all of humanity and be part of that dialogue, that there's this amazing connection we have between our ability to observe and think about the universe. I think that's my favorite part of doing science.